Alright guys, welcome back. So in our last few videos, we went ahead and we generated a custom tool table to match the tool crib that we have in person. We generated the tool path for our wrench, our custom CNC wrench. Now what we're going to do today is we're going to go ahead and generate the tool path, and we're actually going to generate the model for our custom SoftJaws. Now, this is an easier process than I think a lot of people realize. And the reason why we do this, the reason why we have custom SoftJaws is because if we look at our wrench, right, we've got this flange of material that we use to hold this part into the vise. Well, we want to remove that. We need to take that material off. But if we try to clamp this part in just a regular mill vise, it's not going to hold it securely. We're not going to be able to clamp this very well. So what we need to do is to create sort of an adapter, an interface between our part here and the mill vise. And SoftJaws is how we do that. So the way SoftJaws work is we're going to mount each one of these jaw plates to our bench vise. And then our piece is just going to sit down right in here like that. And it's going to clamp and hold that together securely. And then we can come in here with the face mill and just sort of buzz this back plate off. If we wanted to, we could also do more milling on the backside if we had pockets or anything like that. But in our case, we're just going to buzz this off. Now, how do we go ahead and create these? Well, we're going to go ahead and start this by opening up our wrench. This piece here from the last video. Now we're going to go ahead and save this. We're going to save this as wrench SoftJaws, because we don't want to overwrite that new or that file that we just made. So we're going to save this as, let's see, file, open, wrench SoftJaws. Now what we need to do is we need to create a duplicate of these SoftJaws, or of our SoftJaws, over this model. So we're going to go ahead and we're going to start by selecting this surface here, and we're going to create a sketch on it. Now the stock size that we're using for our SoftJaws is going to be 3/4 of an inch thick. So if we go ahead and we draw a corner rectangle, don't do this right now, I'm going to save you guys a step here. That's going to be one jaw. This is going to be the other. This will be 0.75, 0.75. All right, so we've got our two jaws, and we're going to be left with a 1/4 inch gap, or I'm sorry, a 1/2 inch gap in the middle. All right. Well, when we generate the toolpath for this, Solidworks CAM doesn't actually care that we're machining two separate jaws. So what we're going to be able to do is to machine this as one solid homogeneous block. And then when we set up our stock in the mill, we'll set up our two SoftJaws with a gap of a 1/2 inch in between. So we don't actually have to model that gap into our part. So let's go ahead and get rid of both of these. And we're going to start by just taking our corner rectangle and drawing that straight up. So we're going to cover this whole thing. And we're going to smart dimension this. We shouldn't have to, but our dimensions should be 2 inches by 6 1/8. Now we're going to go ahead and extrude this. And we're going to extrude this to a height that mimics our actual SoftJaws. And when we make our actual SoftJaws, they are going to be 1.75 inches tall. So we're going to go ahead, features, extrude boss base. 1.75. Now, this is important. If we select merge results, it's just going to meld this into one big block, and we're not going to be able to do the next steps in this process. So make sure merge results is turned off. We need two separate independent bodies here. And then we can select OK. And you can see here we have our wrench and we have our SoftJaws. Now, how do we separate the two? Well, we're going to do what we call a Pro Engineer move. We're going to go to Insert, Features, and Combine. Now, what we're able to do with this is we can add these two solids together. We could subtract one solid from another, or we can take the in-between where it overlaps. We're going to select Subtract. Our main body, the body that we want to keep, is going to be our SoftJaws that we just modeled. The bodies that we're going to subtract are going to be the wrench. And we're going to select OK. And look at that. We end up with a perfect cavity of our wrench in our SoftJaws. Now we've got all this interior protrusions. We don't want any of that. So we're going to go ahead and cut those out. We're going to go ahead and select this surface right here and create a sketch. We're going to select Convert Entities. That translates that surface into a sketch. And then we can go to Features, Extrude Cut. And we're going to cut this going upwards. And we'll do Through All. And what that's going to do is that's going to remove all these protrusions in here. We don't need these in our SoftJaw. Right like that. Now we have a nice pocket for our material to fit in, or for our wrench to fit in. Now what we're going to do is this sits flush, or the flange on our wrench is going to sit flush on here. We want to give it a little bit of a gap. So we're going to select right here this surface and create another sketch. We're going to convert entities, and we're going to go ahead and extrude this surface up 1/8 of an inch, 0.125. This way we'll end up with a gap between the top of our SoftJaws and that flange that we're trying to remove. That's going to make our job a little bit easier. Right like that. And this looks pretty good. Now this is going to sit in our vise like this. This will be the fixed jaw. This will be the sliding jaw over here. So what we're going to do is we're going to go ahead and generate the toolpath for this. And this is a pretty simple toolpath to generate. We're going to go ahead and save this. And it's freaking out right now because I've already generated all the toolpaths for my wrench. And we don't have our wrench anymore, so we can't find them. So we're just going to ignore all these. And we're going to delete mill setup 1. We're going to delete mill setup 2. And we'll empty our recycling bin. Yep. So we're going to go through, we're going to start this all from scratch now in SolidWorks CAM. So SolidWorks CAM, we're going to define the machine. We're using our mill in inches, and we want to set our tool crib to our manufacturing 3000 tool index. Our coordinate system has changed. We can define by part bounding box vertex. We're going to select this front hand corner right here. Our X is going to go along this top edge. And our Y is going to go along this edge right here. And then our Z should be sticking straight up. That looks good. We're going to go to our stock manager. And we're not going to add any material to this. So we're going to set our Z's to 0. We're just going to use the base stock size that we have because we're not going to be facing this down or cutting this at all except for this pocket in our SoftJaws. Setup, mill setup. We're going to tell our cutter which direction to go in. We're going to select this top surface here. Select OK. We're going to extract machinable features. That's going to leave us with this interior pocket. Generate operations plan. It's going to break it down into a couple of rough mills and a couple of contour mills. And we're going to generate the toolpath. Now let's just go ahead and run this and make sure everything looks good before we start fiddling with this. It's going to rough that out. That looks perfect. It's going to come in and clean up those corners where the 1/2 inch end mill couldn't reach. And then it's just going to buzz this clean. Very nice. So let's go ahead and edit these parameters. And the 1/2 inch end mill and the 1/4 inch, those tools are fine. And we're going to leave all these operations in here. Let's go ahead and edit this rough mill, the 1/2 inch rough mill. Our tool is fine as the 1/2 inch. Our feeds and speeds we're going to set to our standard values of 2400. Feed rate of 10 and a Z feed rate of 2.5 and lead in of 5 is fine. All our standard values. For roughing, we're going to treat this just like we have every other roughing pass with the 1/2 inch end mill. We're going to leave some allowance because we're going to clean this up. We're going to set our cut amounts to 50 thousandths. NC rapid plane is going to be 0.1 for the top of stock. And again, make sure cutter compensation is turned off. And we can select OK. Griping at me. We'll ignore that for now. For our rough mill 2, we're going to edit that. We're going to give this the same treatment. Our feeds and speeds for our rough mill, it's going to be 4 times 300, our surface speed for high-speed steel and aluminum, divided by 0.25. So 4,800, again, our machines can't reach that. We're going to use 2,800. And then our feed rate. This would be about 10 or 11 or so. We're going to slow this down to 8. Just because we're dealing with that smaller cutter, we just want to buy ourselves some leeway. Roughing, we're going to leave that allowance as well because we're going to go ahead and do a contour pass. And we're going to set our max cut amounts to 50 thousandths. NC plane is going to be 0.1 and OK. It's griping at me. It should cut this just fine. And then finally our contour. We're going to go ahead, edit that, and give that the same treatment. Feed rate of 8. .50 thousandths depth of cut, and 0.1 for our clearance plane. Make sure cutter compensation is turned off on all of these. Quiet you. And then let's go ahead and see how this looks. Buzzing that out with the 1/2 inch to remove the bulk of the material. Just going to make quite a few passes on here. It should make about 10 or so. Clean up those corners. And then buzz that clean. Very nice. And then if we look at our total time, we're looking at 18 plus about 10. So about 30 minutes to go ahead and cut these soft jaws. And that's not too bad at all. So what we'd do from here, we'd go ahead and post-process this in our usual fashion. We're going to go ahead and export these as SoftJaws. And then we're going to go ahead and run that. And then we should be able to just take this, load in our aluminum SoftJaws into the mill, space them apart by a 1/2 inch, 0 and run our program. And then we should end up with our perfectly cut SoftJaws. Now again, we don't have to model these as 2 separate jaws because when it machines, it's going to cut both jaws at the same time. We can treat this like a solid object. And then we're just going to include a gap in here so that we have some room to squeeze this part together. Now, if you guys have any questions on this process, go ahead and shoot me an email, leave me a comment, and I will see you guys in the next video. Have a good one.